Hey everybody, we're going to do day one of e-learning. Hopefully this works. Try your best. We're going to see how well we can get you guys through this stuff. I've already had technical difficulties. That's why I'm doing this by hand. You're going to see my hand right on paper. But you guys, hope you're staying safe. Hope you guys are enjoying your time. But let's make sure that we are staying up to date on all the stuff we need to and that we're getting everything that we need. Please leave me a comment on Google Classroom if you guys need anything from me. Otherwise, I'm going to run through these notes. We're going to do 13.4 today, which is day number 7, I believe. Let me check my timeline. Yep, day number 7. And then tomorrow, we're just going to do extra examples. So pretty much, we're going to kind of try to teach you guys a lesson and then review. So if there's anything, again, that you guys need from me, please make sure that you guys ask. All right, we're going to get started here. All right, you guys, so your guided notes here, and if you didn't bring them home, you can just write everything out. Please remember, you guys can pause this video whenever you guys want in order to write stuff down. So you could just kind of watch for a while and then write down after that. So what I want to do first, you guys, is I want to see if you guys remember how to solve for things using geometry. So whenever we do this, we're going to realize that in order to solve for a missing angle, what we're going to do is set up a trig function. And if we label the sides, 20 would be the hypotenuse, 7 would be the opposite side compared to the angle. So the trig function we will use is sine. So I set up sine of theta is equal to 7 over 20. Now in order to solve for the missing angle, I will do the inverse sine of both sides. And this is one that we should not know off the top of our head because it does not come from a special right triangle. So when I do that in my calculator, I will get approximately 20.5 degrees as my final solution. Now that's a review. We should kind of have that from our geometry days, and hopefully you guys kind of remember doing that. But the next thing that we'll do is, we'll say if we're trying to find a missing angle, we will have to solve the equation using inverse trig functions. All right, but there are some limitations to our calculator, and now we're starting to see that we could have angles as large as we want. They go from the first, second, third, and fourth quadrant, as well as all their coterminal angles, which we could do the sine of, 2 million degrees, and that was not in triangles. So we want to kind of elaborate or go past what we already know about. So what we're going to do is I want you to verify using your calculator. I want you to type this equation in, and you'll see that it totally equals 0.985 when you do the sine of 100 degrees. So given the information that we just did, we should be able to solve the following equation and get 100 degrees as our answer. Because if I just take away the 100 degrees, we know that the answer to theta is 100 degrees. But if I take the inverse sine of both sides using a calculator, I'd like for you to do that, you're going to realize that you don't get the same answer. You actually get an answer for theta of 80 degrees. And that can be a little confusing for people. We know that the sine of 100 degrees equals 0.985, but the calculator is saying that 80 degrees is the answer that will give us 0.985. Well, the reason behind this is that there are infinitely many solutions to this equation. And the reason why is that families of angles have the same reference angle. And please remember that once an angle is drawn, the family that he belongs to, or the reference angle, actually takes precedent and is more important. But why did I only draw the family of angles of 80 degrees in the first and the second quadrant? Well, we really have to remember that all students take classes. And this tells us which trig functions would give us a positive answer. So in order for sine of an angle to give me a positive answer, I can only draw the 80-degree family in the first and the second quadrant, because if I was to draw the right triangles, well, then the opposite side would be positive and the hypotenuse would be positive. In the second quadrant, if I drew the right triangle, the opposite side is positive and the hypotenuse is positive. So that would work. I couldn't draw it in the third or fourth quadrant because the opposite side would be negative, and then that would give us a value of negative 0.985. So again, what's very important is the reference angle and the quadrant, and as long as you know the values of being positive or negative. And remember, going right is positive, left is negative, up is positive, down is negative. So really, we could do sine of 80 degrees or any of its coterminal angles will always give us an answer of 0.985, and sine of 100 degrees and all of his coterminal angles would give me a solution of 0.985. All right, let's see if we can apply that on the next page. Since we know that there are infinitely many solutions using inverse trig, our calculator can only give us one. So what we want to do is learn the restrictions. So it's very important you guys remember these pictures or learn them. So inverse sine and inverse tangent must give you an angle in between negative 90 and positive 90. It means we are restricted to the first quadrant and the fourth quadrant. But notice that a fourth quadrant angle has to start from 0 and come down, so it'll be a negative value. You will not start at 0 and travel in a positive rotation to get down to this quadrant. Now inverse cosine is a little bit different. Inverse cosine is restricted to the first and the second quadrant angle. Or sorry, is restricted to the first and second quadrants for its angles. So they would be from 0 degrees to 180 degrees or 0 radians to pi radians. So again, very important that you guys remember the restrictions for inverse sine and inverse cosine. I will always refer back to these pictures in order to help me out, because usually there will be at least 2 solutions. And again, when I say 2 solutions, I mean infinitely many, because they would each have coterminal angles, but I only look at the first rotation. All right, so restricted answer only. We're gonna draw a lot of pictures to help us out. So inverse sine of 1/2. First, I think about where it comes from. I know that this comes from the sine of a missing angle is equal to 1/2. Now, if I label the 1 as the opposite side and the 2 is the hypotenuse side, then I can realize which quadrants I should be able to draw this in. If the opposite side is 1, then I know I can only draw a triangle in the first quadrant as well as the second quadrant. Then I can do a positive opposite side of 1 and a positive hypotenuse side of 2. Now also, I should know that these are triangles that I know. If I'm going to have an opposite side of 1 and a hypotenuse of 2, the reference angle would have to be a 30-degree reference angle for each triangle. But where is inverse sine restricted to? It is restricted to the first and the fourth quadrant. So I will not look at this angle. So all I have to do is say my answer has a reference angle of 30 degrees in the first quadrant, making my final solution 30 degrees, or in radian format, pi/6 radians. Now remember, if you have your calculator in degree mode and you type this in, you will get 30 degrees. If you have your calculator in radian mode to type this in and check it, you will get the decimal equivalent to pi/6. All right, inverse tangent of -1. So when we do this, we think about, well, where does it come from? It comes from the tangent of a missing angle is equal to negative, and you could put 1/1. Well, in order to get this answer of -1/1, you could put the negative with the opposite side or the adjacent side. Now, if you remember All Students Take Classes, it will also tell you which quadrants you could draw this scenario in. If you remember, the All Students Take Classes mnemonic device will tell you where things are positive. And tangent would be positive in the first quadrant because all of them are positive. Third quadrant because only tangent is positive. So therefore, if tangent was going to give us a negative answer, we have to draw it in the second or the fourth quadrant. But when I draw this, I'll realize that one of them is not wanted. If I draw a second quadrant angle and draw my triangle, I could have an opposite side of +1 divided by an adjacent side of -1, which gives me an answer of -1/1. If I draw it in the fourth quadrant, I would have an opposite side of -1 and an adjacent side of +1, and if you divide them, the answer is -1. I also know that the reference angle is a 45-degree reference angle in both triangles because of the family. But the second quadrant is not wanted if I remember where inverse tangent is restricted to. It's restricted to the first and the fourth quadrant. So I keep my fourth quadrant angle. Now the next order of business is, what do I label this angle? Well, you're allowed to travel in the positive fashion to get there, and you would end up with 315 degrees. But that's actually a little too much work for math people. They say you should do the easiest way to get to that angle, which is start at 0 and travel 45 degrees in the negative fashion. So while this angle truly is 315 degrees, it could also be called -45 degrees. So our final answer is going to be in the restricted values from -90 to +90, so -45 degrees, or in radian format, -pi/4. Okay, the next example, secant, is a little bit harder because we don't know the reciprocal trig functions as well. So I might want to flip it after I set up the trig function. I know that the secant of theta would equal -rad2/1. Well, secant is related to cosine, so I could do cosine of theta is equal to 1/rad2, and the negative sign doesn't have to go with the denominator or the rad2, it could just go out in front. Now in all reality, I'm not allowed to put it with the denominator in this example because that is the hypotenuse, and we know that the hypotenuse is always positive when we draw our triangles, so I'll need the adjacent side to be -1. So the only place that can happen is in the second and the third quadrant. If I draw a triangle in the second quadrant, I can have adjacent side of -1 and a hypotenuse of rad2, or I can draw it in the third quadrant and have an adjacent side of -1 and a hypotenuse of rad2. But if you remember what cosine or inverse cosine is restricted to, that will tell you the restrictions to inverse secant, which is the first and the second quadrant. So I will disregard the third quadrant scenario, and this is a 1 rad2 or a 45-degree reference angle. So when we look at that, in order to travel there, we travel 135 positive degrees. Or if you're looking at it in radian format, 45 degrees would be pi/4, and you'd be 1/4 pi short of 1 pi, so the radian measure is 3 pi/4. Okay, next example. Inverse cosine of 1 causes a little bit of an issue, because if we set up where the equation comes from, it would be cosine of a missing angle theta is adjacent side 1 over hypotenuse 1, which is not possible. The adjacent side must be smaller than the hypotenuse, so this does not come from a right triangle, it must come from a quadrangle. So if you remember in section 13.3, in order to deal with quadrangles, we drew a unit circle. If you draw a circle with a radius of 1, this ordered pair would be 1, 0. This ordered pair would be 0, 1. This ordered pair would be -1, 0. And the down ordered pair would be 0, -1. The next thing you have to remember is, well, on a quadrangle, which value did we take? In the cosine of a quadrangle, we took the x value. So if the x value here is 1, 0, -1, and 0, the only solution that would work is our right axis representing 0 degrees. Now the nice thing about 0 degrees, if we look at inverse cosine, is we look at the restriction, and it is allowed to be in between 0 degrees and 180 degrees. So it actually falls on the starting of the parameters. So 0 degrees would be my degree answer, or 0 radians. Next, inverse tangent of 0 is going to be the same case. What we want to do is we want to realize that this comes from tangent of theta equals 0 over 1. But there's no way that we can have an opposite side of 0 and produce a triangle, so it must come from a quadrangle. Now the nice thing is, once you draw the quadrantals once, you can always reuse the pictures. So we go back to the pictures that we drew for inverse cosine of 1, or number 4, and tangent was always the y number divided by the x number. Well, that produces 0 as a final answer. That produces undefined. That produces 0, and that produces undefined. So when I'm thinking of this right here, I actually have two different answers. I have 0 degrees and I have 180 degrees, but I have to remember the restrictions. And the restrictions for inverse tangent are -90 to +90. So when I look at those same restrictions down in this picture, -90 to +90, I realize that I'm not allowed to use 180 degrees. So the only answer I have is 0 degrees or 0 radians. Okay, the last basic example, inverse cosecant. Well, you want to realize that this was a rationalized fraction. You could rewrite this as -2 over rad 3, which would be easier to deal with. So we know that cosecant of a missing angle would be -2 over rad 3, so I prefer to write it using cosine. And I have, sine. So I have sine of a missing angle theta would be the reciprocal of that, negative rad 3 over 2. Again, we don't want our hypotenuse ever to be negative, so the negative sign will go with rad 3, and there are two different scenarios for that. We can have a negative opposite side for a third quadrant angle or a fourth quadrant angle. Then I could put an opposite side of negative rad 3 and a hypotenuse of 2, or I can do an opposite side of negative rad 3 and a hypotenuse of 2. But again, if you remember that to solve this, we would use inverse sine. So the restrictions for inverse cosecant must be the same as that. And if we look at the restrictions for inverse sine, we can only go in between -90 and +90. So when I look back down here at my paper, I realize, well, that's -90. Going all the way to +90, I cannot look at the third quadrant picture. And the reference angle that would be across from rad 3 is 60 degrees. So I'm going to use 60 degrees as my final answer, but it's not in the first quadrant. So I would have to travel -60 degrees to get my angle that produces the solution, which would also be -pi thirds in radian format. All right, the last example. We're going to find theta such that cosine of theta equals -0.278. But they give us a restriction of what they find the final answer to be. They want the final answer to be in between 180 and 270 degrees. So what I'm going to do is I'm going to use my calculator. There's no way I would know this without my head or in my head. So I'm going to do the inverse cosine of both sides. And when I do the inverse cosine of that decimal, I'm going to get a decimal angle, but I'm going to round it to the nearest whole angle of 74 degrees. But when I look at the answer that they give me is, oh sorry, they don't give me 74 degrees. It gives me 106 degrees. Sorry about that. It's going to give me 106 degrees. But whenever I look at the restrictions, that doesn't fall with what they want. So I have to understand families of angles. If I was to draw 106 degrees, I would end up in the second quadrant. And I care about what family he is in. So you guys, he is in between 180 and 106 degrees. So the reference angle would be 74 degrees. Now, you also want to think about all students take classes again. All trig functions are positive, only sine is positive, only tangent is positive, only cosine is positive. So again, I want cosine to give me a negative answer, so I want to avoid the first and the fourth quadrant. So I could draw a 74 degree reference angle in the third quadrant as well, if I understand families of angles. Now if I do 180 plus another 74, I'd be at 254 degrees, which is the angle that they are looking for. If you look at the final answer and the parameters that they gave us, then we know that 254 degrees is our final answer. And if you do the cosine of 254 degrees, you plug it in there, you will get approximately this value. This is just a rounded answer, so it won't be exactly that value. All right, make sure you guys do day number 7 homework. I know that wasn't the most exciting thing to watch, and I apologize for it. We're gonna make do with what we have to do. I'll make better videos as we go along. Probably bring somebody in here to kind of videotape. We'll do whiteboard and all that, but those are to come. Tomorrow, we're gonna do more practice with this. So just try your best to do the homework. I will be giving the answer key out to the homework so you can see if you're doing it well or not. And then tomorrow, we're gonna do more examples. You can always leave me a comment and I will try my best to help you out, or you can wait to the following day and see if a little bit of independent practice by yourself and then extra practice with me tomorrow kind of clarifies things. All right, stay safe out there and remember, it's your boy, Mr. P. See ya.